Okay, good morning again. My name is Hilde Brees and my co-chair is
Kazuhide Ito, Kyushu University.
We will share you the session about IEA annexes in the energy and buildings community annex of the International Energy Agency. For your information, we are proud to have 3 annexes related to ventilation here, 78, 86 and 87 after the lunch break. What we will have, what is the structure? First of all, the operating agent of each annex will present a general overview, short, and then afterwards there is one more in-depth presentation on one of the topics in this annex. So the first annex we will go through is Annex 78. I want to announce Professor Pawel Wargocki from DTU in Copenhagen as one of the operating agents of this annex. Up to you.
Okay, it was turned off, so now it's turned on. Okay, now probably everything is working. So my name is Pawel Wargocki, Technical University of Denmark, and I was invited to make a brief overview of the Annex 78. It's the annex with the title Supplementing Ventilation with Gas Phase Air Cleaning, Implementation and Energy Implications. So this is the outline of my presentation. I will briefly tell you about the annex and what are the elements of the annex and what are our objectives, and then I will explain about the concept of supplementing ventilation by gas phase air cleaning, and then I will be speaking about 2 aspects in the annex which are the most important aspects probably of the annex, is the energy impacts of using gas phase air cleaning and testing of gas phase air cleaners. So, and also I would like to say that the Annex 78 will hold a meeting here in Tokyo in 2 days. So for those who are interested to participate, you can join the meeting here, and I can provide you the details about the agenda and the location. So, and here, this is only an introduction. There is no time to go into details from all the other different aspects in the annex. There are 2 operating agents. Technical University of Denmark is the operating agent, and Professor Bjarne Olesen and myself are the operating agents of that annex. And our schedule is that we basically will complete our work next year in June, and then we will be moving into the reporting phase later this year. So the structure of the annex is that there are several subtasks that will lead to understanding the importance of the gas phase air cleaning with respect to the energy. So one subtasks with the subtask leader, which is Ali Reza Afshari, who is present here in this room, is about the energy benefits using gas phase air cleaning. Is basically trying to rate how much energy you can save by using gas phase air cleaner. And then subtask 2, which I am the leader of this task, is to explain how we can partly substitute ventilation by air cleaning, is basically to provide the evidence on how much ventilation can be substituted by those air cleaners and how we can determine that amount of air that can be delivered compared to the ventilation. And then there is a subtask C, which is the testing of the air cleaners with the subtask leader is Paolo Tronville from Italy. Here is more in looking into what is available with respect to the testing of the gas phase air cleaners, and also what is the need for the development of the new standards for the gas phase air cleaners. I'll be speak about this in a moment. And then finally, one important subtask is just the performance modeling and long-term field validation of gas phase air cleaning technologies. And the subtask leader is Karol Kapela, who will be present later this week during Annex meeting in Tokyo. In this subtask, the objective of that part of the work is to basically understand how what is the performance of the air cleaners during their lifetime, and then basically determine in actual locations and validate the results from the laboratory experiments and predictions of modeling that the benefits that are supposed to be delivered by the gas phase air cleaning are truly delivered. Basically, the concept of that annex is taken from the concept of defining ventilation rates in both standard ASHRAE 62.1 and standard EN 16798, which is a Europeans. In this concept of those standards, the ventilation or the total outdoor air supply rate has two components, and has a people component and a building component. And basically, by acting on any of those components, there could be a saving of the energy. So basically, by acting on the people component, by removing gas phase from people, and by acting on the building component, we can actually replace or substitute some of the ventilation that is delivered by having the gas phase air cleaners. And then for the in order to be able to do that, we need to estimate the clean air delivery rate for the gas phase air cleaners. And then there are methods for the estimating this, and there is a test method for assessing the performance of gas phase air cleaning media devices for general ventilation. And basically, it defines the clean air delivery rate based on the efficiency of the gas phase air cleaner. It is on the reduction of the concentration of a specific pollutant in that is in the space that should be removed by the gas phase air cleaner. However, if we looked at the standards and the methods for testing gas phase air cleaners, they basically use a specific challenge pollutants to test the performance of that, and those are either single species pollutants or the mixtures of pollutants, or sometimes even they use so-called TVOC, which is the a metric that basically tries to look at the additive effect of all the volatile organic or gas phase pollutants in the space. However, it does not take into account, this testing does not take into account several aspects, among others, the aspect of the byproduct generation. So there are challenges that are in relation to gas phase air cleaners, and one of those challenges is that there are very few pollutants that are examined, which is not representing the actual atmosphere that is in the buildings. And then there is also another challenge, is that during the process of the air cleaning, there could be byproducts generated that are basically not considered in those standards. Here I give an example of the byproduct generation because of the incomplete oxidation. When there is oxidants in the space, which produce the unwanted products, often not or not at all actually tested by the air cleaning process, testing of the air cleaners. So this is why in the annex, and there is a need to develop other methods to be able to, first of all, encapsulate the entire effect of the gas phase air cleaners. So, and if we go back to the standards, those standards are based on the acceptability of air quality. So basically on the perception. So basically develop a methodology in which will take into account the perception of the air quality. And then also the methodology that will account for the potential production of unwanted byproducts. Such methodology exists, and this is based on the assessments of perceived air quality and is actually included as one of the methods for testing of building materials in ISO 16028. So the similar approach can be used here, and this is basically how it can be done, is basically by determining the effects of the air cleaner with, or the effect of the air cleaner in comparison with the condition without air cleaner. We can basically determine the outdoor air supply rate. So here is just an example of the effect of ventilation on the perceived air quality and the effect of the ventilation plus air cleaner with on the perceived air quality. And to achieve the same level of dissatisfaction, basically we can reduce the ventilation by using the air cleaner, and that would define our cleaner delivery rate. So there are two examples now so we are working on it, on the methodology, how to do this. But a very important aspect of that annex is energy simulations. So we are looking at the energy simulations, and I don't have much time to speak about it. This is just one example of modeling of the standalone air cleaner that supplies clean air without any byproducts. And then the idea is that we have two scenarios that we want to model. Is scenario that is called F3, which is a building materials and people, and F1, which is only building materials. And the idea is to improve the indoor air quality from the category 4 that is defined by the 40% dissatisfied, or category 3, which is 30% of dissatisfied, to category 2, which is defined as 20% dissatisfied, according to the standard EN 16798. So this is some of the results of the modeling. So important thing to notice here in the modeling results is that we see here the results of the modeling with and without air cleaner, and this is the level of CO2 concentration in the modeled room when the air cleaner is used. It is interesting to notice that in case that we do not have, that when we have an air cleaner, the levels of CO2 are higher because the gas phase air cleaners will not remove the CO2, but they will provide an additional effect of ventilation, but will not remove the CO2. So these are the results of the energy, and this is with using energy, this is including energy use of the air cleaner, and then we see here that the percentage of energy saving depending on the use of the heat exchanger. This is for the different primary energy factors in Denmark. And basically what we see that those effects are in the neighborhood of around maybe below 20%, and all depends on how much heat is recovered on the heat exchanger. And these are a few other examples of results in which we modeled the use of the air cleaner, and depending on energy mix and the use of the heat exchanger, the percentage of energy saving is low, below 20% on average, and even lower. So the simulations for different climates with air cleaner providing cleaner delivery rate. resulting in up to 50% reduction in outdoor air supply rate, but the energy savings reached maximum about 20%. And the other example that I want to show is the development of a new standard for testing gas phase air cleaners performance. I'll be quickly finishing. So in that idea here, we try to develop the standard based on this two-stage testing and using the sensory perception of air quality by humans. In the future, the idea is to replace the sensory assessments by chemical measurements. But at that time, we don't know which type of pollutants we need to measure to represent the effect on sensory perception. We believe that we may be able to maybe suggest something in the near future. So in the testing process, we propose two-stage testing, which is a stage one is to basically pass, no pass stage with respect to the effect on indoor air quality. So basically not implement the complete testing of the air cleaner in case it may produce byproducts. So it's just basically a check whether the air cleaner is producing byproducts. And then if there is the air cleaner that is not producing byproducts, determine clean air delivery rate using sensory assessment. So we have performed some experiments in our labs using this. These are 3 field labs you see with 3 different configurations and with the air cleaners and without air cleaners, with people and building materials inside the field labs. And we had people entering the spaces and then performing sensory assessments. You'll see me on one of the figures. I did not perform the sensory assessments as the recruited panel, but we had a separate panel. This is just only for the illustration. So we had like people entering the space and assessing air quality. And basically we run different protocols. This is an example of the stage 1 results, where we have an empty room without any pollution sources, additional pollution sources with people and with building materials. And on the top line, you see the performance of the air cleaner that did not pass this stage. You see that the acceptability of the air quality reduced when the room was empty, without any pollutants or with people, and only minor improvement in case of the building materials. Whereas in this case of the second air cleaner, we see an improvement of the air quality and no reduction of the air quality when the air cleaner is in operation. So this is just an example of how you can test which air cleaners gas phase air cleaners can produce byproducts. And then we tested those air cleaners under different conditions. It's just an example of this test in which we tested the air cleaner based on at 3 different, these are different types of pollution sources, building materials with people and people. And we tested air cleaners basically at 3 different ventilation rates and also with additional number of units in the space. So this is the development that are happening in our annex. We also do chemical testing to understand better and make a connection to the sensory testing. We understand that sensory testing is very difficult, so we try to basically compare that and see whether there could be any pollutants that could represent sensory response. So I'll stop here. Thank you very much, because the time is up.
Thank you, Pawel. Now we continue. I cannot repeat it. Wait.